Hi everyone, welcome to the second session of the AC400. So we are going to learn about GitHub Actions as well. And actually we will continue talking about pipelines in general. All right, so remember that if you have any question, feel free to post it here into the chat. There is a team answering to all of your questions directly into the chat. All right, so now let's continue talking about the pipelines. So what are we going to learn here? Well, first of all, let's start talking about the concept of pipeline in DevOps. Yesterday, we started talking that what is DevOps. Remember that we say that it's a group of techniques which main purpose is to speed up the process while we are delivering software. And this involves agile methodologies, automation, pipelines, version control systems. So on this day, let's focus on this process, the process that I want to automate. And this process is going to be known as a pipeline, right? And that pipeline, it will be a process. And during that process, we will have multiple tasks. What are examples of these tasks that are going to be executed during a pipeline? For example, you may want to compile an application. You may want to execute unit tests. You may want to deploy your application. All right, so this will be an entire process, and the idea is that we want to automate everything, right? So I will want to automate this entire process. So, and normally, how we want to automate that process, or what will be the trigger that will initiate this specific process? You can specify, but it is very common to trigger this process by using every time a developer makes a change or push a change inside a repositories. So a pipeline enables a constant flow of changes in production via an automated software production line. This will be a repeated process, reliable, and incrementally improving process for taking software from concept to customer. So remember, guys, it is a process that will be fully automated. And that process, of course, can be modified. Actually, within Azure DevOps, we can edit the process by using the graphical user interface, or we can use a YAML definition. So in a YAML file, we can specify all the components and all the tasks that are going to be executed. Other thing that is very important, and is one of the core concepts regarding a pipeline, is that a pipeline requires infrastructure, guys. So it is something that is very, very important. Require infrastructure. So how this is going to impact, or let me explain this. When you are compiling an application, or when you are creating a Docker image, or simple, when you deploy an application, you need the infrastructure that is going to handle those instructions. And this is the same here. If we want to compile an application, we need to provide the compute resources where this application will be compiled, or the compute resources when the Docker image will be created. So it is very important to take the idea that the pipeline requires infrastructure. We will see later that in this infrastructure in Azure DevOps is known as agents, right? So remember, every pipeline requires a compute resource to be executed. Within Azure DevOps, we will refer to as agents, all right? So inside Azure, we have the Azure Pipelines. Remember that each organization allows me to have projects, and within each project, we have, among other services, we have the pipelines. It's a cloud service that you can use to automatically build and test your code and make it available to other users. So actually, within Azure DevOps, it can work with any language or platform, such as Python, Java, PHP, Ruby, C#, and Go. It can be deployed to different types of targets at the same time. And it integrates with Azure deployments such as container registry, virtual machines, Azure services, or any on-premises or cloud target. Now, These kind of pipelines can be divided into two categories. Let me open my browser, and if I go to my DevOps organization, let me select any of these projects. So if you notice, if I click here on pipelines, I will see, of course, I have different options, but let me focus on this part, the pipelines options and the releases options. All right, so inside the pipelines, from general, I have pipelines and I have releases. What are the main differences? In the first stage, or in the first option, which is known as pipeline, this is where I will execute normally. This will be triggered every time a change is detected inside my repo. Actually, if I try to create a new pipeline, take a look. The first thing that I need to provide is where is the code. Normally, the code could be from an Azure repos Git, from the bucket, from GitHub, from other Git. And it is very important that by default, if I choose any of these options, the entire process, all the process, is going to be defined in a YAML file. All right. However, if I want to use the graphical user interface, I can use the classic editor. Right? So in the classic editor, the process will be very similar. I need to specify where is my repo, but the main difference is that I will be provided with a graphical user interface where I can specify all the tasks that are going to be assigned. Right? So let me go back here, and I would like to see this pipeline that was already provided. If I click here on edit, take a look. And this is inside this pipeline, I have one job, and inside this job, I have 1, 2, 3, 4, 5, 6 tasks. So all of these tasks are going to be executed. Let me select here the triggers. Are going to be executed every time a change is made. But actually, at this point, we don't have the continuous integration. So if I click here on the enable continuous integration, this is where I can specify which branch of the repo is going to trigger this specific pipeline. All right. What else? I can also create variables in case that I want to secure those variables, in case that I want to expose the value of these variables directly in the code. And well, with this is an example of a .NET application. Normally, what are the tasks that are going to be executed when we are trying to deploy a .NET application? We will restore the NuGet packages. We will build the application. We will test with a unit test. Then we will publish this and for as an artifact. And the output, it is very important to mention here that the result is going to be an artifact. All right, so from the continuous integration, the result will be an artifact. What could be this artifact? The zip file, could be a Docker image. And the main idea is that once this artifact is created, then we will jump to the releases pipeline. So the releases pipeline, again, is another process. Currently, is not, we cannot edit a pipeline, a release pipeline from a YAML file. We only have the graphical user interface. And if you notice, this process is going to start from a given artifact. If we take a look at this, the pipeline, the first pipeline, I need to start from a given code. With this, an artifact is going to be created. Once the artifact is available, then we can continue with the releases pipeline. So here, from the artifact that was provided is where I can specify multiple stages the pipeline it is going to have. So based on the type of application, based on the type of artifact, based on the resources where you want to deploy, is the task that you are going to have in the in your pipeline. So actually, it is very important to mention that again, based on the type of programming language where your application will be deployed, or if you want to store your image to a specific container registry or to a virtual machine. Now let's continue talking about the different terms that we are going to find inside a pipeline. First of all, there is a trigger. What is going to initiate this entire process? Very common that the process will be initiated by a change in the repository. We can specify which branch, such as the main or any other branch that you have created, and automatically every time a change is detected, automatically the pipeline will be triggered. Inside the pipeline, we can have multiple stages. I don't know, maybe, for example, here, go back to, in this case, I only have one stage, and inside this stage, I will have just one job with all of these tasks. So you can have tasks, for example, to compile your application, to create your infrastructure, to delete your infrastructure, to execute the unit test. And inside the task, all the tasks will belong to a specific job. And very important to mention that, remember, a pipeline requires infrastructure. And in this case, that infrastructure is going to be known as agent. Actually, if we take a look to this pipeline, choose this pipeline again, and if I try to edit, again here, I'm using the graphical user interface, and if I choose this job, I can see here second, or if I select this task, there is an option available where I can specify the agent where this will be executed. In a few moments, we will continue talking more details about the different options that we have regarding the agents, right? But remember that a pipeline is a process. This process is going to have multiple stages. On each stage, we will have jobs, and on each job, we will have tasks. The tasks that you have are going to depend on your specific pipeline. Maybe one task is going to be invoke a REST API, deploy to an Azure App Service, publish an artifact, publish a Docker image, execute the unit test. These will depend on your specific requirements. Now, I was telling to you that every time you need to execute a pipeline, you have to provide the infrastructure. In this case, there's something known as agents. So by default, when we're working with Azure DevOps, we can use the agents that are provided by Microsoft, right? So this is something known as Microsoft hosted agents. Or we also have the option that we can provide our own compute resource. And in this case, this is going to be referred as self-hosted agents. All right, so take a look at this. By default, in this case, I only have the following hosted agents: macOS, Ubuntu, Windows, or in this case, I have my own private hosted agent. You might be wondering, okay, so when I am going to use a Microsoft hosted agent or when I am going to use a self-hosted agent. So a Microsoft hosted agent is a compute resource that is fully managed by Microsoft, and by default, it already has some packages already installed, and you're going to use it if it meets your requirements. Let's say that you want to install or you want to build a Docker image. In this case, if you want to build a Docker image, the agent that you are going to use, the agent that you want to use should have Docker engine already installed. Actually, if you want to see a list where you can get more information about the different packages each agent, Microsoft hosted agent, about each agent has installed, you can access to this documentation, and if you scroll down, you can pick any of these options in order to see which software this agent already has installed. So it is very important to consider that the packages that you need to build your artifact or for your specific pipeline should be installed in the agent that you want to use. In this case, if any of the packages are installed in any of the Microsoft hosted agent, this is when the self-hosted agent comes into play. In this case is where you have the infrastructure, maybe your local machine, maybe another virtual machine. But in that case, that infrastructure will be totally managed by you, right? In that case, you are going to install all the packages that are required to execute your specific pipeline. Now, you might be wondering, okay, but if I want to use my own computer, if I want to use my virtual machine as a self-hosted agent, what is the process that I have to follow? In this case, we need to install a series of packages in that specific compute resource. Let me show you a quick tour here. If I go here to project settings, if I scroll down, I will see something known as agent pools. So in this case, I already have my own pool. And in this case, if I go to agents, I will see that I don't have, I have this agent already installed, but I can click here on a new agent. And in this case, if I can configure for Windows, Mac OS, Linux, I mean, there is a process that you have to follow based on the operating system your infrastructure is going to have. Actually, one of the labs that you are going to work regarding this topic is that you are going to provide your custom self-hosted agents. So remember, when I am going to choose between a Microsoft hosted agent versus a self-hosted agent, well, one of the options is that when you require a specific package that is not supported by the Microsoft hosted agent. Of course, there might be other alternatives. Maybe you don't want to spend, or you want to provide your custom infrastructure for saving cost, maybe. Okay, but most of the time is going to be regarding of the packages. So inside the jobs, we will have 4 types of jobs. We have agent pool jobs, such as jobs that run on an agent in an agent pool. Remember that an agent pool is going to be a group of agents. A container job, jobs that runs in a container on an agent pool, in an agent pool, or deployment group jobs, jobs that run on a systems in a deployment group, or agentless jobs, jobs that run on the Azure DevOps Server, also called server jobs. All right? So let's continue talking about the agent pools. So you can organize your agents. Remember that the agent is the compute resource where the entire pipeline will be executed, right? And inside the pools, we can have multiple agents. So an agent pool defines the sharing boundaries. And one thing that is very important to mention is that each agent pool will be a scope to the entire Azure DevOps organization. What does this mean? This means that remember that inside the Azure DevOps organization, we have agents. In this case, if an agent pool is scoped to the entire organization, so that means that each agent can be shared across all the projects that are available with all the projects that exist within that specific organization. So by default, remember that Microsoft offers different hosted agents based on different operating system. Remember that each agent is going to have its own packages, such as Windows. What are the options? The agent pools. We have Windows Server, we have Ubuntu, we have Mac OS, or we have Windows Server. There are different versions. Each version will have its own packages. So what are the typical situations for agent pools? You are a member of a project and you want to use a set of machines owned by your team for running build and deployment jobs. Or you are a member of the infrastructure team and would like to set up a pool of agents for use in all the projects. Remember that we can share the agents between all the projects that belong to the same organization. Or you want to share a set of agents machines with multiple projects, but not all of them. Basically, is that we are sharing the infrastructure where the pipeline will be executed. Other thing is that the agent determines which jobs it needs to run, report the logs, job status, and the communication is always initiated by the agent. All the messages from the agent to Azure Pipelines are over HTTPS. Okay, so remember that you can use a Microsoft hosted agent, or you can provide your self-hosted agent. Remember, guys, that feel free to ask any question. There is a team here answering to all of your questions, and I will be occasionally taking a look to your to the questions that are presented here. Actually, I have a question here from Jose Luis. Self-hosted agents can be other cloud resources. Yes, you can provide your own virtual machine. You can provide your local machine or any other cloud resource. As long, remember, that you need to install the necessary packages, or you need to follow a process based on the operating system your agent is going to have. Of course, and if you are using another virtual machine, you have to consider the security aspects. Maybe you have a firewall, maybe you have a network security group. But yes, we can provide other cloud resources. What are other considerations? In some cases, we need to be authenticated. We need to provide a personal access token. We are going to have interactive versus service process, and we need to handle the updates within that specific agent. So remember, what is the process? Let me repeat this, because this is something that you are going to do in your lab test. So I can go to the organization settings or the project settings. I could choose the agent pools, and here, when I click on new agent, I will be able to see that based on the operating system, I need to download a package, and I need to execute that package um, within that within that operating system and execute a series of commands. But one of the most important aspects that you are going to provide is the personal access token in order to be authenticated against that specific organization. All right, so how can I retrieve, or how can I request a personal access token? I can click here, I can select personal access tokens. When I click on personal access tokens, in this case, I am trying to provide um, permissions for the self-hosted agents. So I need to choose, or I need to look for the permission that gives me access to the agent pools. All right, in this case, I can choose the agent pools. And when I follow this process, this will give me a personal access token. And that personal access token is going to be used, or it is going to be provided while the process we are installing the packages in our custom machines, in our own machines, in order to be granted as a self-hosted agent. What else? The security of agent pools. Roles are defined on each agent pool, and membership in these roles governs what operations you can perform on an agent pool. So there are different roles, such as a reader, service account, or administrator. So in the case of a reader, members of this role can use the organization agent pool as well as agents. So service account, members of these roles can use the organization agent pool to create a project agent pool in a project. An administrator, so we have the previous permissions, but additionally, members of these roles can register on unregistered agents from the organization agent pool. This impacts when we are working with multiple members and we want to grant permissions to other users in order to manage the agents that exist within the organization. All right, so other thing that can be executed within an agent is that we can execute parallel jobs. So this is a simple example of a Microsoft hosted parallel job. So in this case, we can execute roles that are going to be executed in parallel. So users can collectively run only one build or release job at a time, and additional jobs are queued. And a release consumes a parallel job only when it's being actively deployed to a stage. Other thing that is very important to mention is that by default, our tier will not allow us to have parallel jobs. So for that, you need to run, or you need to provide a subscription within Azure. Let me show you how you can do this. So again, within Azure DevOps, can go here to organization settings. Then if you scroll down, you can see here parallel job. No, sorry. You can go here to billing. And which is when you select billing, you need to provide a subscription that exists inside your Azure account. And once you provide your subscription, then you will be able, in this case, this subscription is no valid. I'm not able to, it's not active, so I'm not able to use that subscription. But in case that I provide my subscription, I will be able to change the paid parallel jobs. So by default, there is a limitation in the free tier, and this is where we need to provide or we need to specify the correct subscription. In that case, you're gonna determine how many parallel jobs you need. So you can display all the build and releases. Parallel jobs are purchased at the organization level and are shared by all the projects. As I mentioned before, there is a limitation when we are executing the jobs directly within Azure. So in this case, you need to answer to the following questions. How do I qualify for the free tier of public projects? So the project must be a public project and build a public repo. There are some limitations on Azure Pipeline. So basically, for example, for the number of parallel jobs, the time that you can use the Microsoft hosted agents, for example, 10 free parallel jobs, unlimited self-hosted build agents, and as a Visual Studio Enterprise subscriber, do I get additional parallel jobs for Azure Pipelines? Subscribers will get one self-hosted parallel job in each organization. So with this, we are seeing the pipeline from a big perspective. But remember that we can, let's continue talking about the different ways a pipeline can be described. So we can create a pipeline with a visual designer, often referred to as classic pipelines, right? So with this, we can edit the code, we can push the code, we can build a task, and actually we can modify all the tasks that are going to be involved during that process. Let me select this project. If I go to pipeline, choose this pipeline. If I try to edit, right? So with this, these are the different tasks that are going to be part. There we go. So this entire pipeline was created or it is defined using the visual designer, often referred to as classic pipelines. So if I want to see the YAML definition of this, there's other way. I can select this pipeline and I can click on these three dots. And if I click on export to YAML, automatically this will create a YAML file. And all this pipeline can be defined with a YAML definition. One of the benefits of having the entire pipeline or all the process in a YAML definition is that we can store it in a version control systems, and therefore we can have control about the different versions this process already had. So again, we can use the YAML definition in a YAML file that exists alongside your code. So in the same repo, all the YAML will be provided. While more code-oriented, defining pipelines using YAML is preferred. I would say that it's more as a standard. So you can configure Azure Pipelines to use your Git repo, or you can edit your Azure Pipelines YAML file to define your build. You can push your code to your version control repositories, one of the benefits of having this pipeline in a YAML definition. Now your code is going to be updated, built, tested, and packaged. Of course, with this will depend on the task, not only if I define the pipeline in a YAML or with the graphic user editor. Okay, so let's dive more into the continuous integration aspect. Remember that normally there are going to be two types of pipelines. A continuous integration and the continuous delivery. Normally, in the continuous integration is where the artifact is going to be created, and in the continuous release is where that artifact is going to be deployed. All right. So what is the continuous integration aspect? The continuous integration aspect is the process of automating the build and testing of the code. The developer or someone makes a change, and that change is going to trigger the entire process. Maybe we want to build, we want to test, but remember that an artifact is going to be created. So CI, for continuous integration, encourage developers to share their code and unit test by merging their changes into the shared version control repository. Right? So in this case, we can have a team of collaborators, and each collaborator is going to push their changes, and since we are centralizing all the code in a single repository, so we can trigger all of this process. When a change is detected, it triggers an automated build system. So the code is built using a build definition, and developers respond to any issues or bugs. Well, CI keeps the main branch clean, ensuring bugs are caught earlier in the development cycle, which makes them less expensive to fix. Now, there are four pillars of continuous integration. What are the components or the core concepts within continuous integration? Version control system. This is where the code is going to be centralized, or is where the code is going to be received by multiple members, and the package management system. So if we need to compile that application, which packages do we need? Think about in a C# application, maybe you need some NuGet packages, or in a Python application, you need some pip packages, or Maven for Java, or Node for JavaScript. And this package is going to be very important because all the packages are going to be installed or must be installed in the agent that we are using to execute this specific pipeline. The continuous integration system merge all developers' working copies to shared mainline several times a day. I mean, all the system that is fully automated. And again, this is going to be in part with the automated build process. So an automated build process creates a software build, including compiling, packaging, and running automated tests. So what are the benefits of continuous integration? It will improve the code quality based on rapid feedback. So automatically, if there is a bug that was introduced, we can detect earlier as possible. We don't need to wait until all the changes are done in order to take it to production. So as soon as the developer makes a change, we can detect rapidly. And we want to be more flexible. We want to react to those events. It will be triggered automatically for every code change. If we want to reduce the build time for rapid feedback and early detection of problems, we want to reduce the risk. Better management of technical debt and code analysis. Remember that there are additional tasks that can be introduced within this process that allow us to monitor technical debt, code analysis, such as it will provide recommendations based on warnings, based on vulnerabilities by specific packages, or maybe a function that is not called anytime. What else? We can reduce long, difficult, and bug-inducing merges, and we can increase the confidence in code-based health long before production deployment. And we can provide rapid feedback to the developer. Right, so what about yourself? Have you tried to implement continuous integration in your organization? If you were successful, what lessons did you learn? If you were not successful, what were the challenges? What I can tell you from my personal experience, of course, if you have a single process that will compile the application, might be not complex, but normally we want to integrate more things, such as such as the unit test. In my case, integrating this with the unit test was hardful at the beginning, very painful. But I think that nowadays we have more processes that are fully automated, and we can when this entire process can apply to the same project that has the same nature. At the beginning was what was hard to implement because all of the unit tests, all the tasks that were involved. But once you have the pipeline for that specific project, or once you have the continuous integration for that specific project, it will be easier to maintain. Right. So what else? Every time a pipeline is executed, it will create its own run, its own execution, its own ID, and its own artifact. Actually, if I select this pipeline again, you can see that this pipeline was executed twice. So if I execute this pipeline again, it will show me another item for that specific pipeline. So each pipeline will have its own version, and each pipeline will have its own artifact. Right? So remember that the artifact is something that is going to be created during the continuous integration part, because that something is going to be passed to the continuous release, to the release pipeline. All right. So remember, each execution will have its own version and its own status. Other thing, one of the benefits of having this is that for each pipeline, let me select it again, is that we can have multiple information. If I click on the status batch, so the last time this pipeline was executed, it went succeeded. However, if it failed, the batch that will display here is going to show us an error. Actually, let me see if I have a pipeline that didn't work, just to show you. Go here to pipelines. Okay, so all of this pipeline has been executed without any error. Let me see this maybe. Okay, well, the main idea is that again, each pipeline is going to have its own status, and the main idea of having this status batch is that it will provide us with this image URL or the sample markdown in case that you want to see the documentation. Maybe you have a wiki, or maybe you have a markdown file where you want to show the current status of that pipeline. What was the result? The result that I received the last time this pipeline was executed. So what else? What other strategies regarding these pipelines? So you can specify you need to consider the capabilities of the system, the agent, and the agents can have different authorization and timeout settings. Or you can specify, for example, to execute process in parallel. You can have multi-job builds. So you can add multiple jobs to a pipeline, or adding multiple jobs to a pipeline lets you break your pipeline into sections that meet the different agent pools or self-hosted agents. So you can have such as this group of tasks are going to be executed in a specific agent. This other group of tasks will be executed on this other agent, and so on. And you can publish artifacts in one job and consume them in one or more subsequent jobs. So with this, based on the strategy that you follow, you can build faster by running multiple jobs in parallel, and you can enable conditional execution of tasks. Remember that we can have processes that are going to be executed in parallel. This also makes it is very benefit when you're having, let's say, data science loads or data science jobs. So in that case, you can separate your data between multiple groups, and instead of analyzing your data as a fully data set, you can split it into multiple data sets, and each portion can be processed by a single job, by a single node. So this is another example where we can apply having parallel jobs. Now, Regarding the type of pipelines, remember that the pipeline can be created by using the classic editor, using the graphical user interface, or by using the YAML file. However, based on the type of pipeline that we select or that we are trying to work with, there are going to be some conditions and some restrictions. For example, the Azure Repos Git, when my code is in an Azure Repos Git, I can execute both type of pipelines. However, if I have a Azure Repos with the foundation, I cannot use the YAML definition. I can only use the classic editor and so on. But the bucket, both are available, either Git or generic in the YAML definition if this is not available. So by default, when I'm using the classic editor, the graphical user interface, all the sources are going to be available. And in contrast, when I am using the YAML definition, just a few of them will be available. All right? So remember, guys, that any question that you have, feel free to ask here in the chat. There is a team answering to all of your questions. Okay, so let's continue. So what is the anatomy of a pipeline? So we have the name of the pipeline. Normally we skip this because by default, automatically a name is going to be provided based on the date. And we have a trigger. What will be the event that is going to initiate this entire process? Normally, it's any change on the main branch. Normally, but of course, you need to change it based on your requirements. Variables. So we can have variables in the pipeline. So again, maybe you want to connect your application to a database and you don't want to expose that password within the code. So in that case, let me select this pipeline. In that case, you can create variables that are going to be consumed by that specific pipeline. In this case, we have the following variables, but of course, I can provide more variables. Job. Every pipeline must have at least one job. The pool. So remember the pool of agents or where the jobs are going to be executed. And the checkout cell tells the job which repository or repositories, if there are multiple checkouts, the checkout for this job. And the steps, the actual tasks that need to be executed, in this case, a script task that can run inline scripts. All right. So again, what is the structure? You have the pipeline. The pipeline is the process that will have one or more stages that describe the CI/CD process. Then we have the stage, which is a collection of related jobs. A job is a collection of steps run by an agent on a server. Remember that this could be a Microsoft hosted agent, or this could be a self-hosted agent. Then we have the step, a linear sequence of operations that make up a job. Then we have the task, building blocks of a pipeline. So all of this structure can also be provided in the YAML file. So again, in the YAML file, we can have stages, we can have jobs, steps, variable. Actually, if we take a look to the pipeline that we have downloaded before, again, so we have some variables here, we have some resources, we have some jobs, and each job we will specify the agent where this will be executed. Then we have the different steps that are going to be part of this specific process. And this is more related to in the case that we are defining this in a YAML file. We have in the pipeline, the repositories, as well as the containers. So you can use multiple repositories in your pipeline. Common for utilities use across more than one pipeline, and you can add additional checkout steps. Well, it's important to mention that this wasn't supported in earlier versions, and artifacts were used as a workaround. And well, some pipelines might not need any repository at all. Now, at this point, we are talking about pipelines, but these pipelines are being executed within Azure DevOps. So this kind of process can also be executed inside the GitHub. So inside GitHub, we are going to have something known as GitHub Actions. So with the actions are automations within the GitHub environment, again, often used to deal CI/CD implementations, and these are going to be based on YAML files linked with GitHub repositories. And again, we can use the GitHub agents or self-hosted runners. It is the same. In order to execute a pipeline, I need to provide infrastructure. I need to provide the compute resources where this will be executed. And one of the benefits of using an open source, well, that in the past was an open source project, is that there is the GitHub Marketplace, where by default there are different extensions that can be used um, in order to your pipeline, maybe an integration with other specific service. So again, what will be the process? You can trigger the pipeline by events that of course within your repository, or you can schedule, or you can trigger manually. And again, you will have workflows, you have jobs, and you will have actions. So here a workflow again is going to be it will be the series of steps that are going to be executed. So we can define the required automations such as event jobs written in a YAML file. Normally, this is going to be stored in a folder with the name .github/workflows. And again, you will have all the definition. Actually, in one of your labs, again, you will execute a pipeline. Of course, you will execute pipelines by using Azure DevOps, but you're also going to have a lab where you will execute a pipeline within GitHub Actions. So what else? You can specify the different elements your pipeline is going to have, such as the name of your pipeline, or the event that triggers the workflow, the jobs, the list of jobs to be executed, runs on the target runner, the list of steps to execute. We use this a predefined action to retrieve and run tells the job to execute a command on the runner. So there are multiple types of events, as I mentioned before. For example, you can trigger the pipeline manually, or you can trigger based on a schedule with a cron expression. You can also specify code events, such as, hey, every time change is made on the main branch or a specific branch. Webhook event, if something happened in you're going to specify your custom endpoint in order to be called by a third-party application or external events. So just like the Azure pipelines, we're also going to have jobs. So workflow contains one or more jobs. Jobs contains a set of steps to execute in order. And jobs run in parallel by default, but can be configured with dependencies. And again, based on the type of package that you require, based on the type of application where the artifact is going to be created, there are different runners. Runners that you can use to execute your workflow. And again, all of this is going to be part of the continuous integration. So example, the workflow here, for example, every time a push is made, it's the name of the pipeline, and these are the jobs. In this case, we are going to use the latest version of Ubuntu, and these are the different steps. In this case, we are pulling the code. Remember that this process will be executed in the agent, right? In the agent, here, the different actions based on the type of application that we are trying to build. Other thing is that within GitHub Actions, we can also have variables that avoid us expose the passwords directly inside that specific application or inside that specific code. And just like we had with Azure DevOps Pipelines, we can also provide the patches. So every time a workflow is executed, it will throw us an error, or the last time this execution. And with this, I mean, this batch is going to have its own URL that can be integrated within your documentation or some in a place where we can see the latest result this pipeline is having. So what are the best practices for creating actions? You should create chainable actions or avoid monolithic actions, where you can version your actions like other code. You can provide a latest label, add appropriate documentation like the README file, or add detailed action.yaml metadata, and consider contributing to the marketplace. So just to point again, that you can create secrets. And the use of the secrets is because, again, if you're working with multiple members in your team, you want to hide some specific values, or you don't want to expose these values directly in your code, this is where the secrets comes into play. And so secrets are not automatically passed to runners and can be passed as inputs or as environment variables. And you should avoid passing secrets in command line arguments. All right. Let me change. All right, so let me go here to the next module, which is about containers. We already talked about, we've been talking a lot about containers, but we haven't explained what a container is yet. So it is very common that nowadays, it is very common to see that DevOps or Docker or containers is very useful in the DevOps role or in the DevOps techniques. Let me explain why. But in order to explain this, first, let me explain what is the evolution of virtualization. Why containers instead of what a container is, guys? So previously, back, I don't know, maybe 20 years ago, we used to have an operating system, and on top of that operating system, we used to install packages. Let's say Python with the X version, or Java with the Z version, just to mention some examples, right? Java with the Y version on top of this operating system. So what are the implications on this architecture? All the Python applications that are running in this operating system must use this version of Python. The same for Java. All the Java application that runs on this operating system should use this version. But what if I suddenly need to upgrade my Python version, or what if I need to work with another version of Python? So with this, I can impact the existing applications that I have on this specific operating system. So in order to avoid having conflicts between the multiple versions, the virtual machines arise. So with this, we're going to pass from having this architecture or having this other architecture. So we have an operating system, and on top of this operating system, I will install something known as Hyper-V. And with Hyper-V or hypervisor, I will be able to virtualize operating systems. So I can have my operating system number 1, my operating system number 2, and my operating system number 3. So I'm having virtual machines. I am virtualizing operating systems, all right? And with this, each operating system will have their own packages that we need. So with this, we are isolating operating systems, and I will be able to handle which applications are going to be executed on the virtual machine that I select, that I design. All right. So what else? Or what are the implications of this architecture? The implications of this architecture is that having an operating system for each application might be expensive or might be very, very heavy. It's not lightweight. All right, so we are going to pass from having this virtualization technique to having containers. So with containers, what we are going to do, the architecture will be slightly similar. We have an operating system, and on top of this operating system, we will have a container engine, Docker, the most common. All right, and with this, instead of having operating systems, instead of having virtual machines, what I will be able to execute here is containers. Container 1, container 2, containers in general. So you are not going to install operating system. You are not going to install virtual machines. You will only execute containers. In that moment, you might be wondering, okay, but what a container is? Let me explain this. A container is a virtualized environment that contains everything we need in order to execute a specific application. Let me repeat this. A container is a virtualized environment that contains everything that we need in order to execute a specific application. So what does this mean? That a container will already have the code, will already have the package, will already have all the necessary to execute a specific application. All right. In that case, hey, how can I containerize my own application? You can containerize almost any application, PHP, Java, Python, databases, SQL databases, NoSQL databases. Almost any application can be containerized. What is the process? First, we need to create something known as Dockerfile. Inside that Dockerfile, we are going to provide all the necessary instructions that are required to build something known as Docker image. Just a Docker image. You are not creating a container. The Docker image is going to act as a template, and based on that template, we will be able to recreate the application. We will be able to create the container, the instance. Actually, a container is an instance of an image, all right? And one of the benefits of this is that once you have a container, or once you have the image, that image can be executed on any platform that supports Docker. So no matter if you're using Ubuntu or Mac OS or Windows, as long as that operating system is supports Docker, or Docker is installed, that container can be recreated. With this, we are avoiding having the classical, hey, it works on my computer, but it didn't work when I take it to production. No, if it's running on a Docker engine, you can make sure, you can be sure that this application will be executed on any platform that Docker is supported. What else? It will be consistent. Note what developers are working with identical code. It is lightweight because it will have far less the disk. We are not installing an entire operating system, and less CPU and memory if we compare against virtual machines. And efficient as deployment, booting, patching, updates. If we take these concepts to the DevOps concepts, so if you have a distributed application, it will be easier to distribute that application because you only have to update the containers on the infrastructure that you are working with. Other benefit of this, as I mentioned before, we are avoiding the classical, it runs on my computer, when I take it to production, it no longer works. All right, and what is other benefit or other example that we can say this? A Docker image is going to be a good example of an artifact. Remember that in the continuous integration, an artifact is going to be created. one example of an artifact is going to be a Docker image. Once you have the Docker image, that will be passed to the release pipeline where we will deploy that specific application. Actually, remember guys that if you have any questions, feel free to post it here into the chat. I will try to answer to all of your questions. However, we also have a team answering to all of your questions. Let me see here. From Enrico, could you provide other real case example about when parallel jobs in the pipeline are needed? For example, Enrico, when you need to update multiple infrastructure, let's say that you have a server in North America, another server in Europe, and another server in Africa, just to mention an example. In that case, you want to update the application in all of those servers, which is not a good idea. We are going to discuss this in a later module, but again, a parallel job will allow us to update those applications at the same time. In data science, where we want to split my data into small chunks, where each chunk is going to be processed isolated. All right? I have another question here. Given that you have some secrets in Azure Key Vault, when will you use GitHub secrets instead of Key Vault? So it will depend. Of course, you can use it, and you can use it whether you want with GitHub or whether you work with Azure DevOps. At the end, it's up to you. Yes, you can use both options. All right. So again, what is the structure of a containers? Remember that we will have the hardware, we will have the operating system, and instead of having hypervisor, and instead of having operating systems or virtual machines, we will execute containers. Remember that a container already has all the necessary requirements to execute a specific application. Actually, here is another discussion. So do you currently use virtualization of any type, or do you prefer to deploy containers or virtual machines? It's a very good question. So in my case, I would prefer to use containers, of course, but at the beginning, it was hard. I mean, it was hard because each Docker file is going to have different. So, I mean, the instructions that you will have in a Docker file are not going to be the same instructions that you're using, let's say, for a Python application or for a Java or for a JavaScript application. So you need to identify, I mean, all the run comments and all the comments that you execute at the console level, as well as all the files that are needed, because based on those files is what you are going to place in your Docker file. However, maybe this is going to be hard at the beginning, but once you know how to Dockerize, once you know how to containerize your specific application, it will apply to any application of the same nature, and we can reuse those instructions, right? And with this, you can create an image and deploy that image is going to be easily, I will say easier than if we use a single virtual machine. Of course, there are other advantages as well as some disadvantages. For example, virtual machine, you're handling the entire infrastructure, all the packages, you have more control about all the environment, so on. But that's the case. What else? When you're working with containers that are common, such as Dockerfiles, that remember that it is going to look for the Docker file, because based on that Docker file, it is where the image will be created. We have Docker pool, where we are going to retrieve an image from a container registry. Then we have Docker run, where the image will be executed. Remember that with this, we are creating a container. Right? Remember that a container is an instance of an image. What else? Let's take a look to a sample of a Docker file. Now, this is how the instructions of a Docker file is going to look like. Always we are going to start with the from comment. The from comment is going to tell us that we want to start from an existing image. In this case, we are trying to look for an environment that already has Ubuntu installed. Inside that Ubuntu environment, we will create this folder, and inside this environment, we will execute the following commands, and we will execute this following comments, right? So there are a series of steps. In this case, we're not containerizing anything. We're just having such as, hey, I want to have an Ubuntu environment, and inside this Ubuntu environment, I will change the path. And once I change the path, I will execute the following command. At the end, we are not doing nothing complex here. Normally, when normally you want to copy all of your files, and once you copy all of your files to your specific environment, there are some series of commands based on the type of application. For example, I don't know, maybe if you're working with a node application, one of the commands that are going to be executed might be node or npm install, npm run, or in the case of a Python application, pip install requirements, or you will execute the servers, right? So based on the type of application that you want to containerize. Other thing that is part of the Dockerfiles is that we can have multiple stages. Right? So in the previous example, we only have a single block or a single stage, but multi-stages in a Dockerfile builds give the benefit of the builder pattern without the hassle of maintaining separate files. And the code progresses from one stage to the next. What are some considerations for multiple stage builds? So adopt container modularity, avoid unnecessary packages, choose an appropriate base, and avoid including application data. What are the services that Azure offer to me in order to work with containers? We have the Azure Container Instance. Well, we say this can be seen as a container as a service. Let you focus on creating your applications rather than provisioning and management of the infrastructure. Of course, you can create a virtual machine, connect to that virtual machine, and install the Docker engine, but this is a manual process. You can use an Azure Container Instance, which can be seen as a PaaS or as a container as a service. You only provide the image, the image, and automatically your application is going to be created. Then we have Kubernetes. Kubernetes is a service that allows me to orchestrate multiple containers. But remember, Kubernetes is open source, and Azure has its own implementation. We can see Azure Kubernetes Service as a Kubernetes as a service, all right? Remember that Kubernetes is an open source, and what Azure will offer to me is an implementation of Kubernetes, and we don't have to worry about managing the entire infrastructure. What else? We have the Azure Container Registry, which lets me store my own images. And Azure Container Apps is another service that allows me to deploy modern application and microservices using serverless containers. And we also have the Azure App Service. Again, this can be seen as a container as a service, but the main difference within a container instance is that, remember, with a container instance, we will fix the compute capacity this instance is going to have. And in the app service, the compute capacity is going to be provided by the plan we already selected, right? So with this, we are done with this module. What you are going to do in the labs, guys, you are going to play with the different styles of pipelines, such as in a YAML, in the classic editor. Then you are going to work with GitHub Actions. You are going to use your self-hosted agent. And one of the pipelines that you will execute, it is going to create a Docker image, and then the Docker image is going to be pushed to the Azure Container Registry. And in the release pipeline, we will grab that image in order to deploy it. All right? Let me change the module. Give me a second while I'm opening the last module for today, guys. We're almost done. Okay, so now that we have covered the release pipeline, oh, sorry, so the continuous integration, now let's discuss the different strategies when we are trying to deploy an application. So normally the traditional IT development lifecycle involves that we have a lot of bugs, a lot of activities, we need to plan, realize, release, and at the end, well, we're not going to have the 100% of value. So many scopes are going to change during a project. We will have a loss of planned work due to technical debt. Um, to do the technical debt. What else? Maybe we're not going to see, there are going to be changes directly. There are going to be multiple, sorry, there are going to be different changes where we are planning the project. So what is continuous delivery? First of all, there are some principles. So the process for releasing or deploying software must be repeatable and reliable. So once we have automated that process will only be executed. So we want to keep everything in source control systems. Everybody has responsibility for the release process. We want to automate everything. Done means released. We want to improve continuously. And if something is difficult or painful, do it more often and build quality in. So basically, we want to automate a process that allows us to just recreate or that allows us to fully be automated. So release and deployment are often coupled. Release is not the same as deployment. And and um, and there are different aspects. For example, a release is like you have a you have the artifact already created, and you need to wait for a specific process in order to be deployed, something like that. A deployment may involve the distribution of that specific application. So a release might have more, it will be more related to a specific version, while deployment is to definitely show this application to all of the people. So remember that inside the pipeline, inside the release pipeline, we can have multiple stages, right? And one of the benefits of having these multiple stages, that one of the core concepts we are going to find here is the pre-deployment conditions, the pre-deployment conditions and the post-deployment conditions. These are going to be operations that will be executed before and after this process, all right? So, for example, maybe before executing this release, we need to query the work guidance, or we need to be approved by a specific member of the team. Or once we have deployed the application, we want to monitor with application insights, with any specific service before taking this to a production environment. This allows us to control the different stages that we are going to have inside the release pipeline. So what are the artifact sources? Build artifacts or package repositories, container repositories, source control systems. So we can have multiple stages. And well, it is very common to ask ourselves if we want to, or if there is not, if there is a need to deploy every day. What is your target environment? Is it used by one team or is it used by multiple teams? What are users? Do they want a new version multiple times a day? For how long does it take to deploy? Is there downtime, or what happens to performance? Are users impacted? So all the different considerations that we must have when we are deploying in multiple stages. What is a stage? Different terms used in various release tools. So you can have multiple phases, or multiple levels. Well, not levels, different steps, or Yes, different parts of your release process, where maybe each stage is going to have its own target environment. It is very common, for example, that one of the stages is to deploy to testing. And once you have test application, then you can move to another stage where it will be deployed to a production environment. We can have long-lived or short-lived environments, purpose and fun environment, and future release and bug fix. Example of the release task are going to be, for example, FTP upload, GitHub release. So at the end, it's up to you depending, remember, on the type of application, the different tasks that you should consider in order to release an application. So a release task are units of executable code used to perform designated actions in a specified order. It will have an extensible module, but there are different tasks that can be provided. So that the release task could be private, or public accessible, access to variables that are otherwise not accessible, reuse secure endpoint to a target server. What are the release jobs? A job is a series of tasks that run sequentially on the same target and can be combined in one pipeline to enable multi-platform deployment. How to use release jobs? Do you see a purpose for release jobs in your pipeline? How would you set up? Of course. And when you have multiple environments and that you want to test it and you want to play with the pre-deployment or the post-deployment conditions. All right. So let's move into the next slide. So the different recommendation, normally you can automate the release, so that release is going to be executed every time a new version of the artifact exists. So let me show you how to do this. In this case, if I go to the release pipeline, I only have this release pipeline, I can edit, and here I can provide if this pipeline will be executed automatically or not every time a new version of the artifact is provided. Or I can provide a schedule such as, hey, I want to execute this by a specific amount, a specific frequency. All right. So, or you can trigger manually. So in this case, I can click here, create a release, and this will be executed automatically. What else? In the pre-deployment conditions, I can specify which person is going to approve or not. Are not control how, but control if you want to deliver multiple times a day. Manual approvals help in building trust about the automated release process. And well, the release gates gives you additional control over the start and completion of the deployment pipeline. Let me show you this again. These are the pre-deployment conditions. For example, here I can specify the approvals, so which users need to approve this. In this case, I'm providing myself. Then I can specify a timeout. If the user didn't approve it, well, automatically this process is not going to be executed. What else? In the gates. In the gates, for example, I can specify. I can check and I can invoke an Azure function, I can invoke a REST API, I can query the Azure Monitor alerts, or I can query the work items. And based on this result, I can specify a criteria in order to say this process will be executed or not. Actually, other lab that you are going to play with is the release gates, where on purpose, while you are executing the release pipeline, automatically, I mean, you will do on purpose something that is going to be failed because you need to approve it, or you are going to query the work items. If the work items didn't work, then you will execute this pipeline, or you can specify, okay, if the first time didn't work, how much you are going to wait in order to evaluate this again. In this case, we will specify 5 minutes. So the first time it won't be executed, but we will have 5 minutes to change the status or the state of this specific work item. And since this will be executed again, the second time it will be executed without any error. You can see this here. It already executed. Let me see if we have the logs. All right. We can release gates. Give me a second. Release gates give you additional control over the start and completion of the deployment pipeline. They are often set up as a pre-deployment and post-deployment conditions. So we can have quality validation, security scan on artifacts, user experience relative to baseline, change management. So we can have different options that are available to protect the quality. Compliance checks, very important. We can also validate if there are work items linked to the release. Is the release started by someone else as the code committer, or is the performance not affected after a new release? No new technical debt introduced, no vulnerability. So with this, we can take more control before executing that specific process. And when we're talking about the deployment, again, we can deploy it to on-premises servers. We can have cloud servers or infrastructure as a service, or clusters or service connection. So at the end, it's up to you where the application will be deployed. Other thing that you can consider in this task is to perform availability test, such as, hey, I will ping my computer resources, maybe my servers, my virtual machines, to see the health, the status health of those specific computer resources. And if they are working as expected, then we can continue working, or we can continue deploying that to production environment. All right, and well, what else? We can also okay, so again, so we can continue performing load test within those specific compute resource. Azure load testing preview. It's a fully managed load testing service that enables you to generate high-scale load. So in order to test how those virtual machines are reacting to that specific traffic. So what else? Let's talk about the different job strategies, such as how I'm going to react in the case that a job failed, how I can deploy again the job. So again, I'm going to have pre-deployment conditions. This is more related with the release jobs, pre-deployment conditions, which are used to run steps that initialize resource before application deployment starts or deploy. Used to run steps that deploy your application. Route traffic used to run steps that serve the traffic to the updated version. Fast route traffic used to run the steps after the traffic is routed. Or again, different events based on the result. Because based on that result, again, we can create a release dashboard, and this release dashboard will give us insights about the results that we obtained the last time these release pipelines were executed. Actually, I think that I have a release dashboard here. Let me show you how this looks like. Scroll down, integrating with Evo, the release gates. Let me see if I have. There will be overlap where a release dashboard is going to be created. And I want to see, and I want to show you if I already have that release dashboard, just to show you, there we go. I think that I have it here. So if I hold here to dashboards, again, I can link to an existing pipeline. So if I execute this pipeline again, more items are going to be displayed inside that dashboard, and I will see the amount of tasks, the amount of fail, orders, the duration time. So it will let you visualize your release process. Same as a plugin process. It will provide you with dashboard widgets. And again, you can share or you can link this with work items in order to react to those specific changes. And just to finish, what are the different tools that allow us to execute continuous integration or continuous release pipelines? We have GitHub Actions, we have Azure Pipelines, we have Jenkins, we have Circle CI, we have GitLab, as well as Bamboo. So what are we covered today, guys? We are done, but let me summarize what were the topics covered today. We start talking about the continuous integration part. Remember that here we are trying to build something, normally an artifact, and this process will be executed once the process or once the so let me summarize again, guys. So what are we covered today? We covered continuous integration, which is a process that or an artifact is going to be created, where normally this will be executed every time a change is detected on the repo. All right, and this continuous integration pipeline is going to have different tasks such as build, compile, pull the packages, create a Docker image. Remember, very important, each pipeline requires its own infrastructure, right? In this case, the infrastructure will be provided by Microsoft. This is something known as the Microsoft hosted agents. And by default, these agents are going to have some packages already installed. If none of these agents, or if I need an agent that is not supported by any Microsoft hosted agent, in that case, I can provide my custom compute resource. And in this case, this is something known as a self-hosted agent. Based on the operating system of my own compute resource, is the documentation that I have to follow in order to become a self-hosted agent. What else? We already talked about the continuous release. Once an artifact is available, the different tasks that allow me to distribute that specific application. As well as we already talked about Docker containers, which allow us to distribute the traffic. Remember that a container is a virtualized environment that contains everything that we need to execute a specific application. And we already covered other alternatives from a big perspective. So remember that we also have the GitHub Actions, we have Azure Pipelines, we have Jenkins, Circle CI, GitLab, and Bamboo. Right? So that's all for today, guys. Thank you so much. I will stay here answering some of your questions, and if not, thank you so much and see you tomorrow. Thank you for joining us today. Um, there's other questions here related with the recording. Well, let's wait for the staff team to answer this because I'm not sure if the records are going to be available. Oh, hey, I have another question here from Xiaomi. Once, can you explain what's the difference between Microsoft hosted and, well, at the end, we have parallel jobs. The difference is between a Microsoft and self-hosted. Remember that a Microsoft hosted agent is where the compute resource to execute the pipeline. Actually, let me share my screen. Remember that when I want to execute the pipeline, by default, Microsoft offers different agents. So if I go here to my pipeline, I can edit this pipeline and I can specify the compute resource what I want to execute this. By default, these are the Microsoft hosted agents. Compute resource managed and provided by Microsoft, right? So in this case, normally these agents, we already have some packages already installed. So actually, I highly recommend you to take a look to the documentation of the Microsoft hosted agents, where you can get full detail about the agents and the packages each agent already has installed. All right. So remember, compute resources provided by Azure that already contain some packages installed. In some cases, we need a package that is not provided by the Microsoft hosted agents, that is not supported by any agent provided by Microsoft. On those cases, we need to provide, or we need to specify our custom compute resources, all right? And our custom compute resources in order to execute those pipelines. Maybe you have a virtual machine, maybe your local machine, or another computer. In that case, this is something known as a self-hosted agent. In the self-hosted agent is where you are going to execute your custom task. And you might be wondering, okay, but what is the process to have that in order to become a virtual machine or my local machine to be a self-hosted agent? In that case, you need to go here to project settings, and in agent pools, you need to create a pool in order to where you want to create or where you want to provide your agents. And the agents, when you click here on new agent, based on the operating system your compute resource have, so is the documentation that you need to follow in order to install, in order to become your compute resource to become a self-hosted agent. All right. I have another question here from Mario. Is AC204 a prerequisite for the AC400? That's a very good question. Like a year ago, AC104 or AC204 were requirements for having this certification. At this point, I'm not sure, but I think that there is a prerequisite. There may be certification and prerequisites related to the AC400. Yes, there are two prerequisites. You have two options. You can choose the AC204 or the AC104. Both of these are options to take the AC400. But yes, there are some prerequisites. Okay, I have another question here from Lowy. When would you use multiple stages in a pipeline versus multiple jobs? That's a very good question. So you can have, remember that the stages are going to have jobs, all right? And the jobs are going to have tasks. However, what makes the difference within in a job? That a job maybe is going to, the job is going to use the same agent, right? So in case, what makes the difference between using one job or other, the agent that you are using might be one of the passes, might be one of the. What else? And in the stages, for example, maybe you want to deploy it first to a testing environment, and once you already test the testing environment, you want to pass to the production environment. Actually, this is something that you are going to do in the release gates lab. In the release gates lab, uh, you will have multiple stages, such as environment number one, environment number two, and remember that you can have the pre and post deployment conditions. So when you want to monitor what's going on the different stages, because you can have multiple environments. Right, guys, we still have time. We still have 14 minutes before ending this session. So I will stay here in case that I can help you with any of the with any question.